Dear learners, welcome you all. In the previous lecture, we had discussed about solar cell parameters and also discussed few problems related to solar cell parameters. In this lecture, we are going to discuss about the factors affecting electricity generated by solar cell. For reference, refer Solar Photovoltaic Technology and System, a manual for technician training engineers, Chatanshan Sholangi, page number 49 to 54. Factors affecting electricity generated by solar cells are conversion efficiency, amount of light falling, solar cell area, angle at which the daylight falls, operating temperature. These are some of the factors affecting generation of electricity. Let us now discuss the factors affecting electricity generated by solar cell one by one. Conversion efficiency of the total light energy falling on the solar cell, only some fraction of light energy is converted into electrical energy. This has been discussed in the previous class. So as I told you, the 100% energy coming from the solar is not converted into electrical energy. Only some factor is converted in electricity, so that the solar radiation frequency is 350 nanometers to 1140 nanometers. Only this particular frequency alone is used for the conversion of electricity. Only this particular frequency alone is used for converting of electricity. Solar cell efficiency is fixed based on the material and manufacturing process. As we have discussed, we have decided to use a semiconductor material for the manufacturing of solar cell. In semiconductor material, we have decided two materials. One is germanium, another one is silicon. In this we are going to use only silicon because the cut-in voltage of silicon is 0.7. So we are going to fix that. As well as while manufacturing a solar cell, it has been decided what material we are going to use. Silicon with phosphorus, silicon with boron. So material has been fixed. After fixing the material, the converting efficiency of a solar cell is fixed. Input of solar radiation. As I told you, input of solar radiation is the frequency is 350 nanometers to 1140 nanometers is the frequency we are going to use. Next is your area. Area also plays a very important role. For India, the solar constant is 1000 watts per meter square. Based on the area, the conversion efficiency is fixed. Higher the area, higher the efficiency, lesser the area, lesser the efficiency. Efficiency is equal to Pm divided by P input into area. Pm divided by solar constant is 1000 watts per meter square. So that is your area. So Pm is equal to Vm into Im. This part has been discussed in the solar cell parameters. So Vm, Im is your real cell output voltage and output current. From that we can fix the efficiency, and this is your solar constant. So area depends upon your solar cell area. So this is the conversion efficiency of a solar cell. Amount of light falling, P input. So intensity of sunlight falling on the solar cell keep on changing from morning till evening. As we have discussed, the sun rises in the east and sets in the west. So the amount of light falling on the solar cell is keep on changing. It is not fixed. 6 o'clock the angle is different. 9 o'clock, 12 o'clock, evening 6 o'clock, it is entirely changing. Throughout the day the sunlight falling on the solar cell is changing. So this is it. When the radiation increases, current also increases. When the radiation decreases, current also decreases. Here the voltage is shown as 40 voltage. This is similar for your solar cell, or it may be similar to a solar panel. Solar cell voltage is 0.5. panel voltage is 30 to 40 voltage will be differing. So depending upon your cell or voltage, this will be increasing or decreasing voltage. Depending upon your cell or depending upon your panel, the voltage can be increased. If it is a cell, the voltage will be 0.7. If it is a panel, the voltage will be 40 to 50. The current rating also decreases based upon your solar light input. For example, solar cell will produce 1 ampere 1000 watts per meter square. For the same solar cell area, when the radiation is 500 watts per meter square, the current rating will be 0.5. So depending upon your radiation, sunlight falling on the solar cell, the current can be increased or decreased. This is the amount of light falling on the solar cell. Solar cell area. The solar cell area plays a very important role for the generation of electricity or for the factors affecting the generation of electricity. Lesser the size of the cell, lesser the current. Bigger the size of the cell, larger the current. The amount of maximum output current or short circuit current for solar cell depends upon the area of a solar cell. This is a small solar cell, this is another solar cell. Comparing to this, it is bigger. So based upon your area, solar cell area, if it is 50 centimeters square, production of current will be 1 ampere. If it is 100 centimeters square, production will be 2 amperes. If it is 200 centimeters square, production will be 4 amperes. If the solar cell area increases, current also increases. If the solar cell area decreases, current also decreases. So for the production of electricity, this solar cell area plays a very important role. Angle of daylight falling on a solar cell. This is another important factor affecting the solar cell generation. So the angle of sunlight which represents the solar cell greatly affects the output power. Solar cell produces maximum power when sunlight falls perpendicular to the surface of the solar cell. Consider an example here. The sunlight falling on the earth's surface, angle is changing throughout the day. If the angle changes, the amount of generation, amount of electricity generated by the solar cell also affects. Consider example, during the afternoon time when the intensity of sunlight is high, consider this is your solar panel. These are your solar radiation falling from the sunlight. It is directly falling on the solar panel. The angle between the solar panel and the solar radiation will be 90 degrees. So theta is equal to 90 degrees. Solar radiation 1000 watts per meter square. This panel will generate the maximum efficiency. Same thing, this is a solar panel. When the light is falling at an angle, 1000 watts per meter square is falling on this panel, but this panel will not absorb 1000 watts. It may absorb 800 watts, remaining 200 watts will be reflected. So at the same time, without the proper angling of the solar panel, we are wasting 200 watts. So angle plays a very important role. Light falling on the solar panel should be perpendicular to the solar cell or solar panel. This is your solar panel. With 0 degree, the power generated from this panel will be 1000 watts. If the angle is 45 degrees, when the angle is 45 degrees, this panel will generate 707 watts. The same panel, same rating, but because of the angle is tilted, we are wasting 300 watts. 70 degree, again the sunlight falling on the panel is decreasing. The generation of electricity is 342 watts. 90 degree, this panel is perpendicular with the solar radiation, so there will not be any generation in this panel, so it is waste of using this. So the angle of light falling on the solar cell plays a very important role. So we have to consider and should be conscious that the panel should be kept 0 degree throughout the day, so that we get the maximum power generation from the solar panel. Operating temperature. This operating temperature also plays a very important role in the factors affecting the generation of electricity. The solar cell output voltage, output power and cell efficiency depends upon the cell temperature. As for the STC condition, standard tested condition, it is 1000 watts per meter square at 25 degrees Celsius. Consider, for example, India. Here the standard condition is given as 25 degrees Celsius. For every 25 degrees Celsius, the voltage will be increasing, or voltage will have a drop. Temperature of the solar cell is 10 degree. You get the voltage as approximately 48 voltage. If the temperatures keep on increasing, consider it is 60 degrees Celsius, the voltage will be decreased up to 38 degrees. More the temperature, the voltage will be decreasing, but the current rating will be fixed. Based upon the temperature, the voltage will be decreasing. So remember that temperature should be at 25 degrees Celsius. For every 1 degree Celsius increasing, we are going to lose 2.3 millivolt. So for crystalline silicon solar cell, the voltage decreases by minus 2.3 millivolt for every degree rise. Same thing, power is 0.45 degree percentage, it is decreased. Efficiency is also decreased by 0.45 percentage. For every 1 degree rise in temperature, there is a drop. So the temperature also affects the generation of electricity. Hope all have understood the concept of factors affecting electricity by solar cell. Let's all meet in the next session. Thank you.